I am Akash Alawat. Today we are going to study about state of the system and processes. State of system. Any physical condition of the system at any instant is called as state of the system. The state of system is specified by properties of the system. Let us understand this with one simple example. Let's take a container partially filled with water and we are supplying heat to this container. Now observe this container at some time, say t1. At this time t1, let us say the temperature of this container will be, let us say 25 degrees Celsius. Now as time passes and we are supplying heat, now after some time at time t2, we will see that temperature of this water will rise. Let's say it's rise up to 40 degrees Celsius. Now this is our system, we know that, and at time t1 its temperature is 25 degrees Celsius. Now temperature is our property, and this, with the help of this property, I am defining this the state of this system at time t1. Now we are supplying heat, that means our system is undergoing some process. After supplying heat at some other interval time t2, its temperature is 40 degrees Celsius, and now this temperature at time 2 will define this state of the system. Now this system undergoes some changes. Now that change in the state of this system is called as process. If any one property of this system changes, then state of the system will also get changed. The infinite state through which the system passes through its initial stage to its final stage is called as process path. Now the process can be classified as whether it will be a reversible process or it will be a irreversible process. A process is said to be a reversible process if it can be reversed in a direction flowing the same path without leaving any change in the system and surroundings. Otherwise the process will be irreversible. Now we will have a detailed discussion over reversible and irreversible process in my upcoming lecture, where we will study about entropy. Now moving further, we can also classify this process as a quasi-static process and non-quasi-static process. A process is said to be a quasi-static process if it takes place in a very slow manner. Otherwise it will be a non-quasi-static process. Now let's have a detailed discussion over quasi-static process and non-quasi-static process, of course. let's let us take an example where we have, first of all, we are learning about quasi-static process. In this example, we have piston and cylinder arrangement. This will be the initial point of the system, point of the piston. Let's assume this piston moves to its final point at point 2. And between this whole process, there are n number of time intervals where piston will move in the cylinder. Let's take it. We will study this piston when it will be at position somewhere between 1 and 2. Let's consider that position be A. Now on this piston, we will attach a pressure measuring device, one on the piston and one on the cylinder head. At equilibrium condition, both pressure measuring device will show pressure of 1 bar, atmospheric pressure, or 100 kilopascals of pressure. Here, let's consider that this piston will undergo a process of compression, where its initial state is point 1 and its final state is point 2. Now this piston is doing compression in a very slow manner. As we are studying, quasi-static process is slow, so we are compressing this piston in very slow manner. Now, as this piston moves from its initial position to its final position, the pressure inside our system or inside this cylinder head will start rising. Now, because it is a very slow process, the gaps between the molecules present inside the system will start decreasing gradually. As the gap between the molecules is decreasing gradually, so our pressure will rise gradually in a very slow manner, not instantly, because this process is very slow. Let us say at some point when it reaches to the pressure, let us say this pressure measuring device is X and this pressure measuring device is Y. At some point A, the pressure at this X will be obviously more than atmospheric pressure. Let us say it reaches up to 150 kilopascal, and at the same time Y will also show the same pressure, that is 150 kilopascals. And when it reaches to its final point, obviously pressure will be more. Let us say at 2, both X and Y shows obviously will show the same reading, and the reading we'll assume to be 200 kilopascal. The maximum pressure at point 2 or at final point we have is 200 kilopascals. Now after reaching its final point, Let's assume it starts its expansion, and that process will be also in slow manner. Now again, the gap between the molecules will start increasing when expansion is going on. So the pressure will get decreased, and we'll observe that at the manner in which pressure gets increased, in the same manner our pressure will be decreased. During expansion also, the pressure at point A will be 150 kilopascals, and after whole expansion our final pressure we will get will be 100 kilopascals or 1 bar. Here in this process, because this process is very slow, in this process compression is also very slow and expansion is also very slow. What we will observe is the way in which compression occur, exactly the same we get our expansion. Now if we consider, obviously we'll in real world we'll have some friction losses here with piston and cylinder. If we neglect those frictional losses, or if we neglect those friction, we can say that this process of compression and expansion, it will be exactly the same. This process follows the same path during compression and expansion. So we can say that this process is reversible. From here we conclude that if a quasi-static process occurs without friction or frictionless, quasi-static process will be our reversible process. In this whole process our properties change uniformly. Let's draw a graph to represent this process. We'll have pressure on y-axis and volume on x-axis. Process of compression. From its initial to final point 1 to 2, here compression occurs in this manner. Now this is the graphical representation of this process. Here I represent this process with a join line, because quasi-static reversible process are always represented with this joined line. Now moving further, let's understand about non-quasi-static process. Here we are also considering the same piston cylinder arrangement. Piston is at its initial point, point 1. This will be its final point after compression, that is point 2. Here let us consider any one position between 1 and 2. Let us consider this position to be A. This will be the piston. Here we have one measuring device X measuring device, and on cylinder head we have also one Y measuring device, that is pressure gauge, pressure measuring device. In initial condition, both of them will show pressure of 1 bar or 1 atm or 100 kilopascals. Now here the only difference will be that during compression, now this compression will occur in a very fast manner. Instant compression will be there. Now in this instant compression, what will happen is, when piston starts moving from its initial position, because our compression process here is very fast, the gaps between the molecule which are nearby to the piston, the gap between them will decrease instantly, not gradually. And the gap between the cylinder head, the molecules present near the cylinder head, at very less instant this compression is occurring, so the gap will remain same at very minimum duration of time. Because this process is very fast, the gap between the molecules nearby to piston will instantly decrease, and at that very particular instant, the gap between the molecules present near the cylinder will not decrease. So the pressure at X at that instant will be higher, and the pressure that shown by cylinder head will be lower. Now let's consider in this process when our piston reaches at A, because here the gap decrease instantly, so the pressure rise will be there, and pressure rise will be far more than its final condition. Let's say here at X our pressure is showing 250 kilopascal reading. Now when it reaches to its final position, the gap between the molecule will decrease, because our condition is same, our system is same, so final pressure, whether the process is slow or fast, will be the same. So the gap, so the pressure shown by this Y here at final position will be 200 kilopascal. But at that instant, when the piston will be at our position A, that here the pressure shown by X will be more, that is 250 kilopascal. Now if we consider this expansion again from 2 to 1, this piston is expanding. It will never reaches that 250 kilopascal pressure. It will directly fall from 200 kilopascal to 100 kilopascals of pressure. Now here the process of compression and expansion is not same. This process can never be a reversible process. I'm drawing this graph here. At y-axis we have pressure, and at x-axis we have volume. State 1 to state 2. Because this process is irreversible, that is why I'm showing this process with dashed line or discontinuous lines. Irreversible process is always shown with this dotted line, dash line or discontinuous line. In this whole process, we reach this 250 kilopascal pressure just because of a rapid decrease of space between molecules which are present near to piston, and which makes this process irreversible, because at initial and final condition our initial and final pressure will be same. If our system pressure if our system is same, our surrounding is same, the volume after the volume in the beginning is same, volume in the end is same, so our initial and final pressure will always be same. But because this process occurs very fast, we reaches more than final pressure somewhere in between this process. The main conclusion of all this explanation of quasi-static and non-quasi-static process is that a quasi-static process is represented by joined line on the property diagrams, whereas non-quasi-static process is generally represented by dashed line because they are irreversible process. In quasi-static process, the properties are uniform, whereas in non-quasi-static process, the properties are non-uniform. And we also concluded that if quasi-static process become frictionless or free from friction, then that process will be our reversible process.